Hi there, my name is Megan and I'm a student studying conservation biology as well as environmental economics and policy. I've been living in Edmonton for the last 4 years, but I'm currently on exchange in New Zealand finishing off my degree. As part of the Alberta Biojet Initiative, I've been working with lead researcher Marty Lukert and his team to study biojet. So today, I'm going to be introducing you to biojet, what it is, why we want to make it, and why not much of it is currently being made. The team I'm working with is an environmental economics group that studies biofuels at the University of Alberta. Biofuels are liquid fuels that are made from living plant matter called feedstock. While almost any biological material can be used as feedstock, common feedstocks include agricultural crops like soybean oil or sugarcane, leftover plant material like corn leaves and stalks, and waste oils like used French fry oil. Biofuels are designed to replace fossil fuels such as gasoline and diesel. But my research has focused on a special type of biofuel that is made to power airplanes. This type of biofuel is known as biojet. Unlike biofuels like ethanol and biodiesel, which have been used to power cars for well over 50 years, biojet was only invented around 20 years ago. This is because jet fuels must be made to withstand the extreme conditions airplanes fly through, and it's harder to make a biofuel that can do this. But why did we want to start making plant-based plane fuel anyway? Over the past year, I attempted to answer this question by reading over 200 publications that discussed biojet, writing down the reasons they listed, and ranking those reasons based on the number of times they were mentioned in the literature. Ultimately, I discovered that there are over 20 of these opportunities for biojet production, but here are the top 3. The number 1 opportunity is the increasing demand for jet fuel. This demand likely results from recent increases in wealth in developing countries, which mean that more of their citizens are flying more often. More demand for jet fuel means a greater opportunity for biojet producers to sell their product. But from an environmental perspective, this increase in air traffic also means an increase in greenhouse gas emissions, which are released when jet fuel is burned in an airplane's engine. These greenhouse gases contribute to global warming, which has negative impacts on the environment and society. But unlike traditional fossil jet fuel, which is made from crude oil, biojet is made from plants that absorb greenhouse gases as they grow. This means that the emissions released by a biojet-powered airplane are balanced out, or offset, by the growth of the biojet's feedstock. In this way, the production and use of biojet can result in far fewer emissions than the production and use of fossil jet fuel. Ultimately, this means that if airplanes are powered by biojet, more flights don't necessarily mean more emissions. The second reason is that biojet is currently the most feasible replacement for jet fuel. While it may also be possible to power planes on electricity or hydrogen fuel, these options pose many technological challenges and would require entirely new, expensive aircraft and infrastructure. On the other hand, biojet is convenient because it can be used in existing aircraft. The third opportunity is supportive government policy. This includes carbon pricing mechanisms like the European Union's emissions trading system. Policies like this encourage biojet use by requiring carbon emitters to pay for the greenhouse gases they create. By flying with biojet, aircraft operators pay less money to the government because they've reduced their greenhouse gas emissions. There are also policies called blending mandates, which require a certain proportion of all fuel sold to be biofuel. One well-known blending mandate is the United States Renewable Fuel Standard. In Canada, you might see the impacts of similar policies when you fill up your car with gasoline that contains 10% ethanol. But even though the vast majority of these blending mandates only require a certain proportion of ethanol or biodiesel, not biojet, many authors think that they may still benefit biojet producers, since other types of biofuel are often made alongside biojet, and since biojet may still receive credits or count towards the proportions set in the blending mandates. But despite these important opportunities, biojet currently accounts for less than 1% of the jet fuel being consumed every year. There are hardly any commercial biojet producers, and many companies either started producing biojet, then switched to other, more profitable products, or just haven't committed to building a full-size biojet plant in the first place. So why hasn't biojet taken off? This was the second question I was hoping to address. So as I was reading all of those publications, I was also recording the reasons for biojet's lack of success. I found that biojet producers face over 40 different challenges, and here are the top 3. As I'm sure you might have guessed, the biggest of those challenges is cost. Right now, it costs around 2 to 4 times more to produce biojet than it does to produce fossil jet fuel. This makes it really difficult for biojet producers to sell their premium-priced product. The biggest contributor to this cost is often the cost of the feedstock. This is because in many cases, feedstocks like crop oils are already more expensive than fossil jet fuel. Another important cost is called the capital investment cost. This includes the price of the equipment needed to make the biojet, which can be very expensive since some production methods rely on extremely high temperature and high pressure equipment. The second biggest challenge to producers is feedstock availability, since most biofuels are made from crops and there is a limited amount of land and water to grow them on. For example, one author estimates that 12% of the Earth's cropland would need to be dedicated to feedstock production in order to satisfy the global demand for jet fuel. In addition, many other industries also require feedstock, such as the ethanol and biodiesel industries. Because these fuels are more profitable than biojet, their producers often use the majority of the feedstock, leaving very little feedstock for biojet. A third important challenge facing biojet producers is sustainability, since producers must make sure that they don't harm the environment or the people living in it while making biojet. For example, research shows that some types of biojet can actually create more greenhouse gas emissions than fossil jet fuel if forested areas must be cleared to grow its feedstock. In addition, using land to grow feedstock can reduce the amount of land available to grow food for communities. Even though the biojet industry faces significant challenges, there are dozens of multi-stakeholder groups working to find solutions. With a little luck and a lot of research, biojet may someday be used in every flight around the world. Thank you so much for joining me today. I hope you enjoyed learning about biojet. I'd also like to give a special thanks to our sponsors who have supported the work we do through the Alberta Biojet Initiative. For more information on this project, you can contact Principal Investigator Marty Lukert at martylukert@ualberta.ca. He's a professor in the Department of Resource Economics and Environmental Sociology in the Faculty of Agricultural, Life, and Environmental Sciences at the University of Alberta. You can also check out more future energy systems research on the website.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.